Good morning everyone. This is Deepa, handling chemistry in Mount Zion Matriculation High Secondary School, and today we are going to discuss about the topic periodic classification of element, that is unit 12. So far we have discussed the lesson matter around us and atomic structure. So based on that we have to study the periodic classification of elements. In this lesson what we are going to study, know the concept of classification of elements in early days and understand the postulates and advantages, limitations of modern periodic table, how to classify the elements based on the electronic configuration and position of hydrogen in the periodic table, study about noble gases and this difference between the metals and non-metals and the importance of alloys in our day-to-day life. These are the things going to be studied in this lesson. The very first introduction, already you know each and every substances are made up of various types of elements. Yes, so each and every substance is made up of various types of elements, and these elements are unique in their nature and the properties. So each and every element have a specific property. So these properties based on these we can classify the elements. Okay, scientists started to categorize the elements based on this. So already now you know there are 118 elements are there. So in 1800 there were only 31 elements. How many elements? In 1800 there were only 31 elements, and 1865 the number became 63. Okay, so in 1800 there were only 31 elements, and 1865 the number became 63, and now you know it is 118 elements. Okay, so is it easy to classify the elements by individually? So if elements irukumbodhu it is not possible to classify the elements as individually. So that scientists gathered more and more information about the properties of these elements, and based on the properties they can be started to classify the elements. So there are various concepts proposed. So here we are going to discuss about the classification of elements, concepts based on the classification of elements. The very first method is Dauberniers triads. Okay, so Johann Wolfgang Daubernier, he is a scientist, German chemist. In 1817 proposed the very first arrangement of the elements, that is how to classify the elements, okay, based on their atomic masses. Okay, so the Daubernier is the first scientist to classify the elements into based on their atomic masses. He arranged the elements into group containing 3 elements each. So he arranged the elements into group containing 3 elements each. Okay, so 3 means tri means 3. So that's why it is the groups are called as triads. That's why the groups are called as triads. Okay. So Daubernier, what he did, he arranged the elements into groups. Over group arrange பண்றாங்க. Each group contain 3 elements. So 3 elements அப்படின்றதுனால it is called as a triads. Nowadays we called as Daubernier's triads. Okay, so what he showed that when 3 elements in the triad are arranged in the ascending order of their atomic masses, the atomic mass of the middle element is nearly the same as the average of the atomic masses of the other 2. Okay, so this is what Daubernier showed in his table. What it is, if he arranged 3 element or group அப்படினா 3 elements சொல்லிட்டோம். So what about the atomic mass of the first and third element? The average should be roughly equal to the middle element atomic mass. அததான் அவங்க சொல்றாங்க. Okay, so we arrange the 3 element in the increasing order of the atomic masses, and the first and third element average atomic mass is equal to the middle element of the atomic mass. So this is the Daubernier triads, and this law is known as Daubernier's law of triads. So this statement is called as a Daubernier's law of triads. Okay, so it may be asked in a 2-mark question, kindly note it down. Okay, so this is the Daubernier triads. So what he did, triad 1, triad 2 and triad 3. Okay, so here this you see the first 3 elements, lithium, sodium and potassium, should be arranged in the first group. So based on the increasing order of the atomic masses, you see 6.9, 23, 39. So what you observed, if you find out the average of the first and the last element, that is 6.9 and 39.1. So if you find out the average, what it should be, it is a 23. So this 23 is equal to sodium. Okay, so similarly for triad 2, chlorine and iodine should be find out the average atomic mass. It should be roughly equal to bromine. Similarly for calcium and barium, it should be roughly equal to 87.6, that is strontium. So Dauberniers arranged 3 elements based on their increasing order of the atomic masses, and the middle element atomic mass is roughly equal to the other 2 elements average atomic masses. Okay, so this was given by Daubernier. So what are the limitations in this? Means Daubernier could identify only 3 triads. So how many triads he forms? Only 3 triads. So at the time there are many elements are found out, but he arranged only 9 elements in this periodic table. Okay, so avaroda triads padi எத்தனை element மட்டும் தான் arrange பண்ண முடியுது? Only 9 elements. So this is the main drawback in this. Okay, the next one is the law was not applicable to elements having very low and high atomic masses. Okay, so elements which have very low and high atomic masses cannot be comes to this category. அதை வச்சு எப்படி அரேஞ்ச் பண்ணுறது அப்படின்றது தெரியல. These are the 2 limitations present in Daubernier's law of triads. So Daubernier's law, what he arranged, so he arranged elements into groups containing 3 elements இருக்கிற மாதிரி அரேஞ்ச் பண்ணாரு. That is called as a triads. And when the 3 elements in a triad, what he did, he arranged the elements into groups containing 3 elements each. That is called as a triads. When the 3 elements in a triad are arranged in the ascending order of their atomic masses, and the atomic mass of the middle element is nearly the same as the average atomic masses of the other 2. Okay, so this is called as a Daubernier's law. This is an important 2-mark question, and the limitation, he could not identify more than 3 triads. So 3 triads மட்டும் தான் கொடுக்க முடிஞ்சிச்சு, அதுக்கு மேல கொடுக்க முடியல, and it is not applicable to having very low and very high atomic mass. Okay, so next we are going to discuss about Newland law of octaves. What it is? Newland law of octaves. So the Daubernier's triad was failed, but his initiative to start to the classify the elements, அவர் தான் first initiate பண்ணினார். So based on that, various scientists proposed their classification of elements. So then after Daubernier, the next scientist John Newland was arranged 56 known elements in the year 1866 in the increasing order of their atomic masses. He also used the atomic mass to classify the elements. So already Daubernier also used atomic mass to arrange the elements. Here John Newland also proposed classification of elements based on their atomic masses. So what he observed is that every 8th element, the property is similar to that of the first element. So over 8 element வருது அப்படின்னு சொல்லி சொன்னோம்னா, after that the first element and the 8th element have the same character, that of the similar properties. So like that, if you have a notes sa ri ga ma pa da ni sa, so musical tone படிக்கிறோம் இல்லையா, so after 7 beat sa ri ga ma pa da ni finish ஆனோன again it start with sa. Like that, the octave of music is similar to the law of Newland octaves. அதனால தான் இது law of octaves அப்படின்னு சொல்லி சொல்றோம். Okay, so the Indian music சரிகமா பதனில எப்படி sa again 7 நோட்டுக்கு அப்புறம் ஸ்டார்ட் ஆகுதோ, similarly if you arrange the elements in particular order, what will happen if the first and the 8th element have the similar character, again 7 element with next 8th element வரும்போது it has a similar characters. So I just show in the table, it will be easy to understand. So here this is the Newland's law of table of octaves. Here hydrogen, fluorine, chlorine, so like that they are arranged. So after the 7 element, again lithium should become. Okay, so both of them have a same character. இதுதான் law of octavesல சொல்றாங்க. So each and every element, அது ஒன்றை விட்டு வரும்போது 8th element must be hydrogen, lithium, borium, oxygen, fluorine, sodium, magnesium இப்படி வரும்போது, so lithium and sodium have a same character, sodium and potassium have a same character, potassium and copper have a same properties. So like that they are explained. So I just explained with the table. So this is the table of Newland table of octaves. Here you see the first element, the hydrogen, and the 8th element fluorine have the same character, and fluorine and chlorine have the similar property. Like that they are explained. Okay, lithium and sodium have a same property, sodium and potassium have a same property. So first la the 8th element ku similar character irukum. This was explained in the Newland law of octaves. Okay, so here the so what are the limitations should be discussed in this is, there are instead of two elements being fitted in a same slot. Okay, so two element can be present in a same so see here cobalt and nickel, so the atomic mass should be different, but both of them are present in a same column. Likewise, diamond and molybdenum, and barium and vanadium, platinum and iridium. So two elements are being to be fitted in a same slot. So this is the first drawback. And the second one is some elements is totally dissimilar in their properties were fitted into the same group. Example, cobalt and nickel, platinum and palladium, cobalt and nickel. Okay, so these should be present in between the fluorine, chlorine, bromine, iodine. These are halogens. In between them, what should be present? Cobalt and nickel. So the cobalt and nickel properties are entirely different from the halogens, but based on we arranged on the increasing order of atomic masses, these should be comes into this category. So this is not possible. This is the second limitation. The third one is the law of octaves was not valid for elements that has atomic mass higher than that of calcium. Okay, so if this law, what he said, the first and eighth element must be equal, so that law should be worked only up to calcium வரைக்கும் தான் work ஆகுது. So more than that, atomic mass அதை விட அதிகமாகும் போது it should become failure. Okay, so the next point is Newland's table was restricted only to 56 elements. You see this table only for 56 elements. Afterwards, nowadays we have 118 elements. There is no space or no new rooms for the new elements. So he could not leave any more space. So where he have to arrange that elements அப்படின்றது சொல்லவே இல்லை. So this is the next failure. So what it is, restricted only to 56 elements. I did not leave any room for the new elements. Okay, so this is the next drawback, that is a limitation in Newland law of octaves. And the last one is discovery of inert gases. So after the discovery of inert gases, what will happen means this 8 octaves rules becomes failure. So what it is means, if helium or any other thing comes inside means it makes ninth element similar to the first one. So far what we have said, the first and eighth element should be have a equal character அப்படின்னு சொல்லி சொன்னோம் இல்லையா. So இப்போ inert gas, that is noble gas, helium, neon, argon, krypton find out பண்ணதுக்கு அப்புறம் what will happen means the first and ninth element should be similar. So example, neon should be present between fluorine and sodium. இது ரெண்டுக்கு நடுவில் நியான் வர ஆரம்பிச்சிச்சு அப்படின்னா what will happen, it should be push out கீழே வந்துடும். sodium கீழே வந்துடும். அப்போ first and ninth element should be same அப்படின்ற மாதிரி வரதுனால this should be failure after the discovery of inert gases. So these are the limitations given in Newland law of octaves. So what he said, so every eighth element had the properties similar to those of the first element. இதுதான் அவரோட law. So he arranged the elements according to the increasing order of the atomic masses, and if you arrange it like that, so what are the limitations means, two elements being fitted into the same column la varudhu, and the second thing, some elements is totally different that should be present in between to the some other group based on their increasing atomic mass la arrange பண்றதுனால. Okay, the third one is it was not valid for the elements having high atomic masses more than that of calcium, and the last one is after discovery of inert gases, it was failed to explain the law of octaves. It is the first and ninth element become equal வர மாதிரி ஆகுது, and he did not leave any more space for the new elements. Okay, so whatever at the time la எத்தனை element இருக்கோ அதை பேஸ் பண்ணி he give a table. So these are the limitations discussed in Newland law of octaves. Okay, so today I hope you all are understand the two classification, early classification of elements, that is Daubeney triads and Newland law of octaves. Go through it. Meet you in your next session.